So wrap up our histogram. Please make sure that you look at the slide on Blackboard where it tells you what a good what the Minitab commands are, and also just above that will tell you good practices in histograms, how you should do that. So just make sure that you look at the different PowerPoints on Minitab and making histograms. So we're going to look at another way that we can represent quantitative data. It's called the stem and leaf plot, or stem plot. Your book calls it a stem plot, but you'll see it called stem and leaf. And it's just a different way to represent your data. And I always say it's just a histogram turned on its side. What happens is you're going to have data, and you're going to take, and look at the example here, for the number 173, and depending on what your data is, we're going to have the stem being 17 and the leaf being 3. In other words, our units digit is the leaf, and our stem is the hundredths and tens place. So let's look at an example, another example. Let's look at the raw data. 5.6, 6.5, 7.3, 7.8, 7, that should be 7.8, excuse me for that. And then there's all this other data, and then there's the remainder of the data. Look how we would input our stem and leaf. Now somehow you have to let somebody know that you're going to have your leaves being the tenths place. So 5.6 would be represented as 5 as my stem and my leaf being 6. 6.5 right below is 6.5, and then here we have our streak of 7s. 7.3, 7.8, 7.8. So yes, you do put in your repeaters, and you like to have the leaves being in order from smallest to largest in increasing order. So as you can see, look, this is just like a histogram. If we turn this to its side, it would be a histogram turned on its side. So we see that the 9s is our greatest, where our data lies, 9.2, 3, 4, 4, 5, 5, 6, 6, and 9. Now things that you need to know about a stem plot or a stem and leaf plot is that your stems will be in ascending order, and you don't leave out a number. So let's say that we had no 15s. What you would see there is 15 and then nothing here. When we see a 0, that means 14.0. So be very careful on that. So there could be a time where you have a stem plot where one of the categories don't have anything in it. It just means that there are no data for that particular class. So just make sure that you put everything in ascending order. Even the leaves should be in ascending order when you put those in. So as I said, the stems are just like your classes. The leaves are like the heights of your bars. Now the advantages of doing a stem and leaf is that it's really quick. It's a quick way to sort your data. It contains more information than your histograms because you actually see the raw data. Now, you can only use it for small data sets, so that's like a disadvantage there. And histograms are more flexible in the choices of classes, which we talked about in the last two audios that I have made. So let's look at this example. Here's our data, 8.6, 11.7, 9.4, and so forth. We have our sorted data here at the bottom, so it's not, we have it sorted. So what I would like you guys to do is I want you to do a stem and leaf plot. I would suggest that you stop the tape, do it, and make sure that you see that you get the answer or the stem and leaf that I get. So this is what the stem and leaf would look like. Now I'm going to change the data just a little bit, and we're going to do another stem and leaf together. So hold on while I get to the next data set. And it's going to look very similar to this one. Now let's look at this data set. And what I'd like you to do is put this in a stem and leaf. So my suggestion to you would be to go on and pause the video and to make the stem and leaf with this new data. And there's the sorted data right here at the bottom. Go on and do the stem and leaf. Now, this is the stem and leaf that comes from here. Please do not be tempted to put a 0 here. You don't want to say that there are 0 9s. And the way you show that is you put nothing there. That's how we know that there's no zeros, because when we have 0, remember, that means 11.0. Now let's look at a stem plot when we have data that goes to the hundredths place, and it's a lot harder to represent this because our stem will be still the units and our leaves will still be the tenths place. What happens to the hundredths place? Two different things could happen. If you just took the raw data and did the stem plot, Minitab will, by default, truncate it. So in other words, it will literally just lop off the hundredths place. So 0.05 becomes 0.0. 0.97, they just truncate, meaning they just lop off the 7 and leave it 0.9, so you see 0 and then the 9. That's what happens if you just do it strictly stem plotting and Minitab truncates. Now, if you take that same data and you round it, so 5.37 becomes 5.4, 3.06 becomes 3.1, and so forth, and then you do the stem and leaf, then you have 0.1, 1.0 is right there, 1.0, because 0.97 rounds to 1.0. So if you look, the plots look a little bit different when you round your data as to just truncating the data. So just a little bit when you're modifying the data. Side-by-side bar graphs are really nice when you're comparing two different things. We're looking here at a McDonald's and Burger King, and we want to compare the two, where we're looking at amount of fat. I think it was fat in each of the grams of fat in their burgers. And as you can see, Burger King has a lot more sandwiches that have a lot more fat in it than McDonald's, just by looking at the comparison, the side-by-side. Now, taking the weight data in your PowerPoints, you can go on and construct a stem plot from that, where the stems are the hundredths and tenths place, and the units make up your leaves. So 203 means 203. And you do have to let somebody know, give them the key to your stem plot. Now, another type of representation, which our book doesn't go into, but it's very good, is called the dot plot. And this is that Wendy's example again. And this is just taking the raw data, the number of people that came through the drive-thru at a certain time, and you literally just place the dots above when one person drove through that was only seen one time, when two people, 1, 2, 3, 4, 5, 6 times you saw that, or is that 5? 6 times. Now, number 7, there was a mistake. It's missing 1 dot. There should be 4 dots on that particular dot plot. That's what we call a dot plot. And again, it's a quick and dirty way to do a histogram. Very useful information when you're taking your data and you look at it very quickly. Dot plots and stem plots are great. So we've looked at, for qualitative data or categorical data, we looked at pie charts and bar graphs. Then for quantitative data, when we did the discrete, we had our histograms. And also with continuous, we did our histograms. Well, with the histograms with discrete, we had our number in the midpoint of the bar, but the bars were touching one another. Whereas with continuous, we had ranges. And remember, when our discrete got too many values, we treated it like it was continuous and made categories. We showed dot plots and stem plots. Now, the very last installment for this chapter is going to be looking at the shapes of distributions. So that will be in the very last installment. Thanks. We'll see you next time.